Okay, so when you make these triangles, you always start out with an acute triangle, a good looking triangle here. What? Yeah, good looking triangle. So alpha is here, which is 37. Whatever angle they give you, put it on the lower left-hand corner. Because if you just put it willy-nilly or anywhere you want, you're going to get confused and you're going to get me confused, and then I won't be able to help you very much. So here we go. So 37 degrees there. Since that's alpha, A is opposite of it, 3.3. And C, whatever other side they give you, put here, 12.6. Okay? We're going to draw a good-looking triangle. And we're going to draw another triangle with 12.6, 3.3, and 37, alpha. Now, it says C is 12.6, so this is gamma and this is beta. Gamma and beta. Okay? So those are our two instances of the triangles. Now, we're going to do law of sines to this one. Just fairly normal. Sine of 37 over its opposite side, 3.3, equals the sine of gamma over 12.6. Okay? So you take 12.6 times the sine of 37, press equals, divided by 3.3, press equals, and that's what the sine of gamma will be. Well, what's the sine of gamma? Somebody, calculator. 12.6 times the sine of 37, press equals, divided by 3.3, press equals, and you get 0. Do you get 0 point something? 0.823 what? 2.297. You know what? If we take and then solve for the sine, if we take the sine to the other side, do you know what happens? Nothing happens. You can't solve for this one. There are no possible solutions. Let's go down and check the answers. I'm pretty sure this one is no solutions. So what is this? And you're going, huh? Mr. Beersbach, you taught all that and then it's nothing? Well, what happens here is this. In this side angle side situation, it looks like that. 37, 3.3, and 12.6. What do we got here? Well, we got a dangle. And a dangle doesn't ever touch this line down here. So is it a triangle? No, is it just a dangle? And we're not solving for dangles. Because if you do the inverse sine of this, you're going to get an error on your calculator. Because this is bigger than 1. And when you're graphing normal sine, did you ever go above 1? No, not unless it was a sine or 2 times the sine of something. So yeah. Sorry, I gave a kind of a bad problem right off the start. So let's hopefully this one, I don't think this one's a dangle. So I think you'll have 2 triangles on this one. So let's see what we start with on this one. All right. Alpha is 44.7. So this is alpha. A is opposite of that, 8.9. B is 10.3. So this is beta, and this is gamma. Okay? See, every problem's a little different. Gamma went here that last time, and beta went up there. It just depends what letters you're given, where you put them. So alpha, beta, gamma. So this is 44.7, 10.3, and 8.9. Okay, so law of sines for this one. Sine of 44.7 over 8.9 equals the sine of beta over 10.3. Do opposites. So you take 10.3 times the sine of 44.7, press equals, divided by 8.9, press equals. What's the sine of b equal to? A couple more. Whatever. It's a number. Okay, somewhere around there. Now on your calculator, because that's what the sine of B equals. We want angle B. So we have to put the sign on this side. So you push second sign, second answer. Second sign, second answer. And the answer is that negative sign down at the bottom next to the equal sign. And then press equals, and what is angle B? 54.5 to one decimal place. That's what angle B could be, but doesn't have to be. So, on your unit circle, if you remember your unit circle, what's the sine of 45 degrees? Or what's the tangent of 45 degrees? 1. What's the tangent of no, this is sine. I wanted sine. Come on, Mr. Bierschbach. Don't be making mistakes like that. We're doing law of sines here, not tangents. What's the sine of 45? Square root of 2 over 2. What's the sine of 135? Square root of 2 over 2. They're the same thing, right? So there are two different angles with the same answer. So here, there's two different angles with the same answer. What's the relationship between 45 and 135? They're 90 degrees apart, or if you take 180 minus this, you get this. Or 180 minus this, you get this, right? So if we take 180 minus this, we're going to get angle B. What's 180 minus 54.5? 124.5? 180 minus 54.5? I don't think so, Shanty. $125.5. All right. Because what I want you to do is press the sign. I want you to take the sine of 125.5. What is it? Something like that, I bet, yeah? And then if you take the sine of 54.5, what do you get? The exact same thing. Thus, the law of sines in the ambiguous case. It's ambiguous here. Now, so in this triangle, how many angles and how many sides do I have? 2 angles, 2 sides. Over here, how many angles and how many sides do I have? 2. So how can I find the third angle over here? 180 minus those two. Okay? So 180 minus 54.5 minus 44.7. And so you should get like 80.8. That was pretty good math. Almost stellar math there. All right. And then what's this angle up here? No. Yeah. I would say so. Like 10.8? 9.8. See, I was off there. I wasn't using stellar math there. Okay. So then how do I find side C? Well, it's just the sine of 80.8 over C equals the sine of what we started with, 44.7 over 8.9. I don't want to use 54.5 because it's a rounded answer. Okay? And then over here, I'll take the sine of 9.8. Sine of 9.8 divided by C equals the sine of 44.7 over 8.9. So take this times this divided by this, and this times this divided by this, and then what do you get? Yeah, numbers. Okay? So you kind of get it? It's opposite of 44.7. Opposites. Okay. Are we good there? So then you just fill in your answers. And this is always the obtuse triangle. This is the acute triangle. Okay? All right. Let's look at this one. Okay. Now, right at the start, you see angle B is how big? 155.8. How many obtuse angles can there be in a triangle? One. So how many total triangles could this be? One. Because if you have side-side angle, you can't have, how this works here. You had an acute one first, and then you had an obtuse one. Well, if we start out with an obtuse triangle at the start, you can't have another obtuse angle in that obtuse triangle. Okay? So we start out, if you're given an obtuse angle right at the start, it's just a normal law of sines problem. Because there can only be one answer for this. Okay? So there you go. The sine of gamma over 5.2 equals a sine of 155.8 over 15.8. So you take this times this divided by this, hit equals, and then do inverse sine of the answer, press equals, and you get what this angle is. And once you have two angles, then you can find the third angle and use law of sines again. Okay? So what's this angle if you do your math? I bet it's fairly small. What? 7.8? So if this is 7.8, then 180, or add these two together, that's 163.6. So if that's 163.6, this would be 16.4, right? So then you'd go the sine of 16.4 over its opposite side, which is A, because if this is gamma and this is beta, then this has to be alpha and A. So sine of 16.4 over A equals the sine of 155.8 over 15.8. Cross multiply solve. Okay? You can do that. So here's another start with an obtuse angle. Okay? Now, if it ever gives you on these obtuse ones an error on your calculator, then how many triangles can it be? 0. There can't be any triangles. Okay? So there are 6 problems for you to play with. Okay? Some of them work differently than others. Should we do this one? This one's a little different also. Okay? Well, you can't see, but then I can't draw triangles very well. No, I'll do it your way. All right. So if we do this one, and we do the sine of 78.8 over 12.5 equals the sine of beta over 9.1. Take 9.1 times the sine of 78.8 divided by 12.5. So if you do that, what do we get? We get some fairly small angle. How small is that angle? What? No, then do inverse sine of the answer. So it's a 45.5 degree angle. So if this is 78.8, and if you go 180 minus 45.5, you get 134.5, right? Add these two up. That's over 200. Can you have an angle like that? No. So you won't have an obtuse triangle in this situation. You only have just one acute triangle. So then once you find that 45.5, you figure out what this angle is by subtracting from 180, and you do law of sines to figure out C. And it's going to be this. There's only one triangle in this situation. Okay? So I'm going to let you work so that I can filter around and help you out on some of this. But yeah, law of sines, the ambiguous case when you're given side-side angle, is a little bit more difficult. You got to work at it a little bit more. So I will put it out there.